Hello, I welcome you all to this another interesting screencast, and the problem reads: determine the normal force that a 100 pounds plate A exerts on the 30 pounds plate B. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So the assumption also here, the assumption is there is no friction. There is no friction between the pulleys and the cables. Okay, or just between the pulley and the cable. Okay, so if this is the case, then we expect the tension force to be the same on both sides. So let's do a section here, we do a section there, we do a section there, we do a section there. So we are going to have tension force T, tension force T, tension force T there, tension force T, tension force T, tension force T, tension force T, and tension force T. Alright, and then we have the weight. The weight of A is the weight of A is 100 pounds. Okay, and the weight of B is 30 pounds, right? So we are going to apply the equations of equilibrium. We just use one, which is summation of forces in the Y. We know that the tension is going to be the same because each of the cables will rearrange itself so that the tension over the pulley on one side will be equal to the other. And because of symmetry, this particular system is symmetrical about this axis. That's the reason why the tension this side is the same as the tension the other side. Okay, so because of symmetry, we expect the tensions to be the same. So summation of forces in the Y equal to 0 going up in our reference. So how many T's do you have? We have done the sectioning. We are just considering this body here, this one here, like so. Okay, this is the one we are working on, right? So this one, what does it give us? What does this one give us? It gives us 40 minus 100 minus 30 equal to 0. Therefore, T will be equal to just 130 divided by 4. This gives us 32.5 pounds. So now let's come to our question. We have been asked to determine the normal force that a 100 pounds plate A exerts on B. Alright, let's draw this. So we have this plate A, okay, this plate A, and then of course we have a tension there that we just calculated of 32.5 and 32.5. Alright, and it has, we have, let me just write this properly. So this is a 32.5, and we have this weighs 100 pounds. Okay, so we are going to have a normal force on this, because as this particular plate, okay, as it rests on plate A, as plate A rests on plate B, there's going to be a normal reaction. Okay, so we're going to have a normal reaction force on plate A, and then the same normal reaction will also be exerted on plate B. Okay, so let me say that is plate B. So we have a normal reaction force of equal magnitude there. This is plate B, and plate B also has its own weight, which is equal to 30 pounds. And then we have T there of 32.5 and T there of 32.5. Alright, so now we want to find this normal force that plate A exerts on plate B, which is this one, right? It's the same normal force. So let's use this particular free body diagram to find this normal force. It's the same, even bit we use the upper one. So summation of forces in the y direction equal to 0, going up being our reference. So we have 32.5 plus 32.5 minus n minus 30 equal to 0. This normal force is therefore going to be equal to 32.5 by 2 minus 30. So we get our normal force equal to 35 pounds. Okay, and it's the same value also up there. If we are to use this, we'll find the same solution. Okay, and we expect the same. So summation of forces in the y equal to 0. Okay, what do you have? We have 32.5. Let me write down. You have a 32.5 plus a 32.5 minus 100 plus n equal to 0. Our n here is going to be equal to the same, 32.5 by 2, and then minus 100. Then we get n equal to 35 pounds. So it doesn't matter which one you use, you still arrive at the same solution. So our n, which is the normal force, that the 100 pounds plate exerts on a 30 pounds plate B, is equal to 35 pounds. Okay, and we found the value of T. Right. So I think this is really about it. And I hope the video was helpful. And if it was, give me a thumbs up, like my video, and continue subscribing. Bye bye, and see you in my next screencast.